All right, I'm not as tall as Kartik. Thank you, Kartik. Hello everyone, I'm Kate from SMEC and I'm here to talk about preparing your landfill for capping and closure. Hopefully my voice holds out. It's been dicey all week. All right, we'll start with an acknowledgement of country. I would like to acknowledge the traditional custodians of the land on which we meet today and pay my respects to elders past and present. About me. Am I pointing at? Hey, there we go. So, I'm a civil engineer. Don't let my youthful good looks deceive you. I've been working in this industry for almost 20 years. I'm excited to be in a room full of landfill nerds, to be honest. I'm sure you can all appreciate trying to explain to people what you do. I started working at Tamworth Council as an undergraduate under Peter Resch. I'm not sure if we've got any Tamworth people here today. I've been chasing a few of them down. I remember being told by him, I'm pretty sure my first day, kept saying this word leachate, and for the kids in the room, that was before smartphones, and I was sitting there going, I don't know what a leachate is, and I couldn't run off to the toilet to Google it. What is a leachate? I don't even know. So I know a lot of our jargon and terminology can be a little bit impenetrable. Having done this, we'll hop to it in a minute, but having done landfills for a while now, I'm trying to demystify some of the jargon and some of the processes. I've been working at SMEC in Newcastle for 14 years. If you haven't heard of it, you're in good company. Lots of people haven't. It's the Snowy Mountains Engineering Corporation. It's another engineering consultancy. It was spun out of the back of the Snowy scheme, which is its own fun story. It covers all of the major disciplines: roads, geotech, water power, enviro approvals. I'm sure I've offended some of my colleagues by leaving someone out, but that's the key landfill-related bits. The waste team has been growing rapidly. Our New South Wales waste team has approximately doubled in size in the past 18 months. Supported by the broader SMEC team, the waste team has staff up and down the East Coast, and we have colleagues all across the country and internationally. As was alluded to, I have a broad civil background, and I started in subdivisions, stormwater, roads, and I spent a lot of time designing water and sewer until I accidentally sidestepped into the glamorous world of landfills almost 10 years ago. Like most people in the industry, I didn't grow up telling my mum that I wanted to be a landfill engineer when I grew up. But it turns out that landfills are really interesting. I was surprised when I started at the lack of prescriptive rules and, standard drawings, standard things that you do. Something as pedestrian as water and sewer reticulation. They have rule books, over an inch thick each. And I picked up the design guidelines for landfills. I'm like, where are all the rules? Where's the rules? So that can be a blessing and a curse. And so the following is a bit of a summary of practical constraints, things that site operators can do to make my life easier when it comes to design, hopefully saving time and frustration and money for all. I think the slides will be available from the conference later, but if you're after these in particular, there's a PDF on my LinkedIn page under presentations as well. I've been learning how to LinkedIn. Hooray. All right, so this isn't actually a cap. This is one of my projects. This is the first one that I did by myself as the design engineer with the training wheels off, and I'm quite proud of it at Port Macquarie Council. It's a snazzy time lapse of the whole thing being constructed, and that's something else that we would definitely recommend for these construction projects. It's just a proprietary product. We don't sell it, but we have lots of clients that use them. It takes a photo every 10 minutes, and you can tell the contractors that so you can make a pretty time lapse for your presentations, but honestly it's just useful to be able to keep an eye on what's going on every day. And we were able to monitor our construction projects all across the country somewhat remotely. So yeah, you can see Cairncross being constructed there. You'll be coming across, there's a lovely flyover at the end that shows the stormwater separation bunds, which are there to minimise leachate generation. So I'm going to jump ahead. We don't need to watch all of Cairncross being built. Go watch it. It's on my LinkedIn. You can see the stormwater separation bunds. We're very proud of that one. Oh, there they were. Terrific. All right. On to closure. Water flows downhill. Water management is a key principle of landfills. Everyone likes to think landfills are about garbage, or sometimes my geotechnical colleagues tell me they're geotechnical problems. The majority of the significant issues that we see at landfills are water-based. A quick primer, we've got a broad church in the room, as we always do in landfill presentations. We have 3 water streams. We have leachate, which is dirty garbage juice, water that's touched waste. We have sediment-laden water, which is water that's run off day cover, so it's picked up sediment soils, looks like a chocolate milkshake. And you have clean water, which is storm water, which is run off the grass. When you're planning your site, obviously you've got high sides, you've got low sides. I spent 5 years at university to be appropriately qualified to tell you that water will flow downhill. You need space at the bottom of the hill for your leachate and sediment dams. Obviously you understand the operations of your site. Of the 3 water streams, sediment is the most relevant to capping. We'll go there in a second, but I left myself a note. I'm not talking about leachate today, but the other question that everyone comes to ask me is my leachate pond big enough? And I will say, it depends. How much leachate do you make? And then you will say, I don't know. So it's tricky. Go get some flow monitoring. That helps everybody. Back to capping. Sediment is the most relevant to the capping projects. So if your capping is broad-scale earthworks, then to put down your low permeability layers across the top. The most economic way of doing that is with large machines, rip, tear, bust, off you go. You want to have it all open all at once. It's probably the largest sediment load that your dams will ever see. So we've seen regulators, hello to the regulators in the room, aggressively prosecute against sediment water discharges. I would argue they're perhaps not the most significant of environmental issues that can happen at a landfill, but they are very easy to prove. We've had clients who've been issued 6-figure fines, so it's boring, but boring things are still important. You should understand the capacity of your sediment dams, so both cubic metres and how much area they can support in what rainfall event. We use terminology like a 80% 5-day storm, so that means that 80% of the time you should be able to catch 5 days worth of rain. So it starts to rain, it fills up over 5 days, gives you some time to deal with it, either to flocculate, treat, or just let it settle and discharge. So you can divert clean water out of your sediment catchments. You will have, when you're capping, a conflict between your operational use of your sediment ponds and your capping works. You both want to use the same pond. If you have a breach, whose fault is it? Make sure your contract documents say. And that is water. The only thing that matters is the edges. So I started doing this. My boss said this to me. It took me about 3 goes for this message to sink in. You look like a bright audience. We'll see if we can get you there a bit faster than it took me. So this detail, there we go, hey, is a standard cap, 2016 cap with geosynthetics. That's New South Wales terminology that's sort of similar all across the world, the world and Australia. That detail there is like 90% of the work, right? Put down some dirt, put down some low permeability, more dirt, more grass, off you go. The trick is what happens at the edges. The edges are constrained, so we need to think about your fence. We need to think about where your property boundaries are. We need to squeeze in access tracks around the outside for monitoring and other uses. And we need to think about the drainage infrastructure, the open swales that we were discussing before for our water, which is flowing downhill. The cap also takes some room. So over here you can see the problem is we actually folded that guy down because we ran out of room. But the cap itself takes some room at the edge. So the key message is here that your waste can really only go to there. So if you're placing waste, don't put it all the way to the fence, okay? Give yourself a margin at the edge. Space makes everything easier. If you're tight to the edges, get a proper cadastral survey. Most surveys don't include a full boundary definition. It's a little bit more expensive than a normal one, not anything outrageous, but it's just more than normal. It's not normally needed. The database extracts, I would say, are normally within 1 or 2 metres accurate, but I've seen some rural ones that are up to 7 metres out. So if you're getting jammed at the edges, you're doing work at the edges, work out where your edges are. Clear definition of the edges helps. All right. I pointed to the right spot. Don't set your landfill on fire. So I know we've been discussing this elsewhere on batteries. This is about rural fire. A lot of our landfills are surrounded by beautiful native bushland. These guidelines are from the New South Wales Fire. I'm sure you can steal them for any state you like. They provide some really simple, useful guidelines for what they're looking for. And if I flip to the next page, there we go. We have down here, this is the key message, is every 250 metres you need space to pass or you need or turn. And so you can see here we implemented it at Cairncross. Here's my Port Macquarie landfill. Here and here. So it's not hard. You could also just do it with like a gravel turning head or something like that. So it was baked into the consents for Cairncross. It was required, but having seen it and how easy it is to do, I would recommend it to everybody. Let's keep our rural fire service volunteers safe. Means on a single lane access that they're able to turn around and escape in a worst case situation. Slopes. All right. This is aimed at helping you to answer the question, how steep is your landfill? Again, a quick primer, we have a broad audience. Engineers, we use 3 ways to talk about slopes: a 1 in something slope, a percent slope, or a degree slope. Here's a handy little table to convert between all of them for you. 1 in X is just rise over run, if you remember your triangles from school. So if you have 1 metre contours on your site, what is the distance from one contour to the next? It's 5 metres. That's a 1 in 5 slope. You can also measure it yourself. I have an iPhone. That's just the standard measure app, and you can just use it to measure degrees off horizontal. So you can go and measure it. This was my family holiday recently, my poor children. That's a road that is 1 in 5. It is steep if you are trying to push your whining children up it. The key message on slopes is, so we need to worry about our edges and we need to worry about our slopes. We're talking here about various examples of slopes that are relevant for landfills. You might all know Victorian landfills officially cap out at 1 in 5, although I know there are plenty which are steeper. There's plenty of 1 in 3s, 1 in 4s in New South Wales where it hasn't been regulated. And I've seen plenty of waste slopes up here in this range. And when I expressed concern, they said, well, it hasn't fallen down yet, which is also a good metric. Just don't ask me to bless it. Okay, so if you're steeper than 1 in 5 on your edges, that's where we need to start being concerned. So if we're putting in the geosynthetics, they're slipperier than a soil material, which we might have used for capping in the past. And the risk is if you're too deep or you're too slippery, is that your whole cover might slide off and end up next door, which is clearly suboptimal, as my brother would say. If you've got something that's steeper than 1 in 5, it's not impossible. There's more engineering that's required. There's procurement risks and issues, and I can talk you through all of those fun things. Just make sure you plan and give yourself some time. Utilities, in-ground and overhead. Where are your utilities? You don't know? You're in good company. Nobody ever does. We've hit more utilities than I care to admit in the investigation works we've done at landfills. If you can spend some time working it out or working out your best guess on what is in the ground anywhere where there might be earthworks or where we might be doing geotechnical investigations, it just saves a whole bunch of headache for everyone. Obviously, you can use a service locator, you can access your own site operator knowledge. Often the operators have been there for a really long time. You can use a surveyor to put it on a map. Councils should have access to a GIS department, so you should be able to. I've always been amazed that councils seem to do water and sewer and stop there. You should be able to get your GIS department to do it. If not, surveyor, and if you want to do it yourself, I'll give a shout out for QGIS, which is open source software. You can find your nearest computer-inclined millennial and get them to map it for you. We use that product a lot as well, supporting our remote clients, sending us photos, locating them. The use of technology is really supporting us. I'm going to reel along. Extent of waste. How much area do I need to cap? Some sites are really well planned, and that's known. A lot of our historic sites in New South Wales are a little bit higgledy-piggledy. On day one, I want you to tell me the edges of where do you need this cap to go. We can do extent of waste investigations, but you don't need an engineering degree to dig a hole and to determine if it's waste or not waste. It's certainly something you can do yourself. We would suggest notching the side at 20 to 50 metre spacing, mark a stake, extent of waste, write the test pit number, take a photo, say we've got some records, have the stakes collected by a surveyor, put it on your plan. See, you don't need me. Oh, and be cognisant of your waste exhumation obligations. Some of our clients are concerned about waste exhumation and that you might need a permit. Don't forget that one. Relocation of waste. So this is something that people often don't think about, but so for anything with geosynthetics, which is a lot of the caps these days, it's like wrapping a Christmas present. It needs to be smooth and it needs to be regular. It can't be a hummocky, hilly mess. So we always have to do a bit of cutting and filling. You can see my cut and fill there. Red is cutting, blue is filling, yellow is leave it where it was. So that's the earthworks that had to be done at this site to make it regular enough to be able to line it. People like to imagine that I can take that up into 300 mils underneath the geosynthetics, and it never quite works out that way. So be aware that that's required. Again, waste exhumation obligations. Sometimes we prepare waste exhumation management plans just to step through the OH&S side of those. Or, even better, save yourself all this trouble and just fill to the right profile to start with. So if you've got top of waste contours and fill to those, it saves you a whole lot of problems. So I think we're not doing questions now, so I'll pass it off. But thank you for your time. Thanks for listening to me, and hopefully you've left with a better understanding of the steps we go through to achieve capping and closure.